Are you looking for a very small, teeny tiny vision language model to fine tune on a very niche use case? Maybe have a look at this new LFM2 VL 450 million parameter model. The only thing which I see could be a drawback is the license, which is LFM1. I'm not sure what exactly that license entails to in terms of using it commercially, but do your own due diligence there. In this video, we are going to install this LFM2VL on our local system, and we will check it out on few of the prompts with images to see how exactly this model works. This is Fahad Mirza, and I welcome you to the channel. If this is the first time you're dropping by, please like the video and subscribe to the channel, as that helps a lot. I have been covering this Liquid AI's LFM models for quite some time, and they have been evolving pretty nicely. The good thing is that not only they release the model, but they also release a lot of information around training and other techniques which they have been using. So do check it out, their model card, and I will drop the link to it in video's description. So I will be talking more about the training and architecture of this model, but for now, let's get the installation underway. I'm going to use this Ubuntu system, and my GPU card is NVIDIA RTX A6000 with 48 GB of VRAM. I'm creating a virtual environment. If you're looking to rent a GPU on very good prices, you can find the link to Massed Compute in video's description with a discount coupon code of 50% for range of GPUs. So please do check them out. You will find their link in video's description. I also want to introduce you quickly to our sponsors of the video, who are iGent, which is the world's first multi-agent workforce desktop application, empowering you to build, manage, and deploy a custom AI workforce that can turn your most complex workflows into automated tasks. Now let's install all the prerequisites, which include latest versions of Torch, Torch Vision, and Transformers. While that happens, let's talk a bit more about this model. So the model architecture features a hybrid design that pairs language model towards either 350 million or even 1.2 billion parameters with SIGLib2 NavFlex Vision Encoder. The model's standout architectural innovation lies in its native resolution, processing up to 512 by 512 pixels, which avoids the distortion and computational overhead of traditional upscaling approaches. For larger images, it uses an intelligent tiling strategy that splits content into non-overlapping patches while maintaining global context through thumbnail encoding, with an efficient two-layer MLP connector that significantly reduces token count through pixel unshuffling. On more non-tech side, the model's primary utility centers on providing fast, lightweight, multimodal AI for resource-constrained environments, delivering 2 times faster inference speeds on GPU compared to existing vision language models in same or similar sizes, while maintaining competitive accuracy. But we will check it out. Now, it also comes in 1.6 billion parameter size, which of course is more reliable and accurate, and even 1.6 billion in vision is quite a small size, by the way. So check it out. And one last point I want to mention is the training approach combines joint mid training that progressively fuses vision and language capabilities with supervised fine tuning on curated dataset, and they have shared a lot of other information on their model card, so please do check it out. Meanwhile, everything is installed. Next step, what I'm going to do is to launch my Jupyter notebook. You can also use a Python code if you like, but I think for the demo purposes, it will make sense to just launch this Jupyter notebook in the browser, of course. And now let's first download our model. And I'm going to change this 1.6 billion to just 450, and these are the same instructions if you're interested in the other one. And the model is being downloaded. It is just over 9 meg of size. And the model is downloaded, as you can see. Now let's do the inference. Okay, so here all I'm doing, I'm just giving it an image from my local system, and it will also display the image, by the way. And then it's an image of a three-way lane, and I'm asking it which lane is open. And then rest of it is similar, where we are encoding the input to the model through tokenizer. We are generating the output with some hyperparameters, and then tokenizer is decoding it, and we are printing the response back. So I'm just going to run this. Let's go back. There you go. So this is the image, and I asked it which lane is open. It says the image shows a highway with multiple lanes. The lane that is open is the one labeled lane closed. Which one? So totally wrong answer in the center. This lane is marked with a red cross indicating that it is closed. Yes. The other lanes are labeled this, but these are not open lanes. Thereafter, the lane, you see, this is called as hallucinating. So 450 model, well, failed the first test royally. If I show you the VRAM consumption, it is actually consuming quite a lot of RAM given its size, like just under 1.5 gig, I would say. And remember, the model is just 450 million parameter, which is a bit of a bummer, I would say. Now I will ask it a couple more questions. If it doesn't really do well, maybe we will go with the 1.6 billion one. Let's try one OCR one. So the model is an English model, so I'm just going to do the OCR of a text on an English text. So I'm just asking it to extract the text from image. Let's run this. This is my text. Let's compare. And if I check it out, looks pretty good to me in terms of OCR. What do you think? Yep, I think it has got almost everything right, which is quite good. At least we have a 450 model which can do a decent English OCR, pretty fine. Okay, let's do an English handwritten one to see if that works. So this is a handwritten one. It says, let's check it out. Yep, looks pretty good. Remember, 450 million parameter model. It is fairly good. Sorry, I'm also checking as with you. Yep, I think for OCR it is not bad. 450 million. I think for edge devices, very small devices, this could be good. But remember the VRAM consumption. Just to check it again. Yep, it is staying at just 1463. You can run it on CPU, right? Okay, so that is good. Okay, next up, I'm just going to give it this chart and I'm going to ask it explain this. It's simple. Let's see if it can read the charts. Okay, that is quite good. Yes, it has got it right, as you can see. And then divided into two sections, left bar, and then it is talking about all the ratios and frames. And also there is a legend. Yes, there is a legend. You know what? I think this is quite good because it's a comparison and it has given me properly. Very nice. Good, very impressive. Okay, let's check out another one. So I'm going to give it an image of two girls and I'm asking it, are these two girls sisters or just friends or a couple? Let's see. And this is the image. AI generated one, by the way. It says it's difficult to determine with certainty whether these two girls are sisters or just friends or a couple based solely on the image. The setting and their interaction suggest a close relationship. They appear to be engaged in a serious conversation, which could indicate a romantic connection. Okay. Without more context, it's not possible. Pretty good, you see. Model also has very nuanced streak to it, which is quite interesting. Very interesting. Next up, I have given it this math equation and I have asked it select correct answer to math equation. Let's see. So it is sort of a reasoning it a bit. Very nice. And then because I haven't printed everything there, so you can increase this. Maybe I will increase this to, let's say this, and then run it again. Let's go down. It is streaming through. There you go. The model is even doing well. There you go. Yep, the answer is correct. Well done. And finally, I'm asking it to convert a table into JSON, and this is a table. And if you look here, I'm not sure if it has done right. Maybe it has. It has tried. So you see, root system, within root, it has gone with this. It has tried, but it's not correct. Okay, so maybe we'll just, instead of we'll just ask it maybe um, what are the, maybe I'll just ask it about the table then. What are the columns in this table? Or maybe column title, maybe, let's see. And then we will ask a question mark. Let's see if it is able to do that. It says root system, this. Last one is not really correct, but other than that, it has got it quite right. So look again, 450 million parameter. I don't think so there is much point in nitpicking. Pretty impressive stuff. Again, use case in my opinion is to fine tune it on very niche set of images and then tailor it as per your use case. That's it. Please like the video and subscribe to the channel, and because that helps really a lot. Thank you for all the support.